Hey everyone, and welcome back for another deep dive. This time, we're going to the moon
The moon.
with India's Chandrayaan-3 mission.
Okay.
We're going to be looking at a brochure today from the Indian Space Research Organization, or ISRO,
Okay.
and they're trying to do something really cool.
Yeah.
They are not just going to the moon,
Yeah.
they're going to be attempting a soft landing,
Huge.
and they are going to be sending a rover to explore the surface.
yeah, that's going to be really interesting to see how this all plays out.
Yeah, this is a big deal, not just for India, but I think for all of, sort of the future of space exploration.
Yeah, I think it really is exciting because it's not just about getting to the moon. It's about demonstrating that you can land softly and you can do some science there.
Right.
It's like the next step
Yeah.
to maybe thinking about Mars or beyond. So that's what makes it really exciting.
So let's break down this mission.
A little bit. Chandrayaan-3 has three main parts. You've got the propulsion module, you've got the lander module, and of course you've got the rover.
Mm-hmm.
So you can think of this as kind of a team effort.
Yeah.
Each one has their own sort of task.
Yeah.
And the mission is divided into 10 phases. So it's a carefully
Oh, wow.
choreographed space ballet
Right.
to get everything from, Earth-centric to moon-centric.
Absolutely. And I think that phased approach is so important
Yeah.
because space travel is so complex
Yeah.
and there's so many different challenges that you have to overcome.
Right.
Each stage has its own risks and its own rewards.
Yeah.
It takes meticulous planning, precise timing.
Yeah.
A lot of smart people at ISRO to pull all that together.
Now, one interesting thing that I saw about the propulsion module is it's going to be carrying a payload called SHAPE.
Interesting.
Now, that stands for Spectropolarimetry of Habitable Planetary Earth.
Oh, wow.
So essentially, they're going to be spying on Earth.
Interesting. So like looking back at Earth
From the moon?
from the moon.
Yeah. So that's kind of cool to get that different perspective.
Yeah, and it could actually give us some really important information about our own planet.
Right.
So looking at the atmosphere,
Right.
Climate change, maybe even help us in the search for life on other planets.
Interesting.
So it's like holding a mirror up to the Earth
Yeah.
from 250,000 miles away.
So this propulsion module is going to be hanging out in lunar orbit for up to 6 months.
Okay.
Kind of keeping an eye on things after it drops off the lander and the rover.
Yeah.
And it's not a lightweight.
Right.
It is over 2,000 kilograms when it's fully fueled up.
Oh, wow.
That's heavier than a car.
Yeah. I mean, all that weight is basically fuel.
Yeah.
To escape Earth's gravity, you need a lot of energy.
Right.
It's like trying to throw a ball really, really high.
Yeah.
It takes a lot of energy to do that. And then it has, a pretty robust power system, almost 750 watts,
Wow.
which, you could run a small apartment on that.
Yeah.
That's to keep everything running, to keep the science instruments going,
Yeah.
and to communicate with Earth
Yeah.
from such a great distance.
Now, the lander and the rover are kind of our dynamic duo.
Yeah.
They're the ones that are going to be doing a lot of the exploring, but they're working against the clock because they only have one lunar day to get their work done.
Yeah, and a lunar day is much longer than an Earth day.
That's right.
Yeah, it's about 14 Earth days of sunlight,
Wow.
followed by 14 Earth days of darkness.
Right.
So you've got to be super efficient with your time.
Yeah. They need to get in there and do what they need to do.
Absolutely.
So the lander itself weighs over 1,700 kilograms.
Wow.
It's carrying a whole science lab.
Yeah.
Onboard needs a lot of power to run everything 738 watts, to be exact.
Yeah, it's incredible to think about, that limited mission life
Right.
due to the day-night cycle.
Yeah.
It's like trying to cram a whole semester's worth of field work
Right. Yeah.
into just 2 weeks.
Yeah.
Right. So the ISRO team, they had to choose the landing site very carefully
Right.
to make sure they could maximize the scientific output
Yeah.
during those precious 14 days.
And now for I know everybody's been waiting for, we get to the scientific instruments.
Okay, the good stuff.
This is where things get really interesting.
Yeah, it's like a high-tech detective kit
Yeah.
designed to unravel the moon's mysteries.
Exactly. So the lander has 4 main instruments.
Yeah.
The first one is called RAM BHALP.
Ramba HALP.
And this is going to be studying the near-surface plasma,
Okay.
which is basically supercharged particles that are floating around.
So understanding the invisible electric winds of the moon in a sense.
Right. And then we've got APXS, which is our elemental detective.
Okay.
So imagine you're using a tiny little X-ray gun
Right.
to figure out what the lunar rocks and the soil are made of.
Okay, cool.
It can identify things like magnesium, aluminum, silicon, and even trace amounts of heavier elements.
And that's crucial for, understanding the moon's history,
Right.
its relationship to the Earth.
Yeah.
It's like comparing baby pictures
Yeah.
of the Earth and the moon to see how they've grown and changed over billions of years.
Then we have LIBS, the laser blaster.
The laser blaster.
Yeah, so this instrument is going to be using a powerful laser
Okay.
to zap tiny bits of the moon's surface.
Wow.
And then by analyzing the light from those mini explosions,
Okay.
they can figure out the elemental composition.
So you zap a moon rock with a laser,
Right.
and it tells you what it's made of.
Right.
That's pretty neat.
And this could help us find rare elements
Right.
or even water ice hidden beneath the surface.
Yeah, which is, one of the big goals of lunar exploration these days. Is can we find the stuff that's going to help us live and
Right.
work on the moon?
Exactly. And then last but not least, on the lander, we have CHASTE, which stands for Chandra's Surface Thermophysical Experiment.
Okay.
It's a mouthful,
It is.
but this is going to be measuring the thermal properties of the lunar surface, so basically how well it conducts heat.
Yeah, and this is going to be so important for, figuring out how the temperature changes during the day and the night,
Right.
and designing future lunar habitats and rovers that can, survive those extremes.
Yeah, and of course, let's not forget the rover.
Yeah.
The rover is going to be carrying 2 scientific payloads of its own.
Yeah.
It's going to be rolling around collecting more data.
Right?
And then up above, you got the propulsion module hanging out
Yeah.
in lunar orbit, doing its own thing with shape.
Yeah, you've got multiple science missions all in one.
Yeah, so it's pretty cool.
It's a fantastic example of how space exploration drives innovation.
Yeah,
And, the things that we develop for these missions,
right.
they have applications here on Earth.
Yeah,
Communication, material science, even medicine.
yeah. It's really cool stuff.
Absolutely.
So we've got our spacecraft packed with science instruments.
Yes.
It's ready to unlock all the moon's secrets. But how do we get this thing to the moon? Well, this is where we need India's powerhouse launch vehicle,
Yeah.
the LVM-3 M4.
Okay.
That's a pretty cool rocket.
Yeah, this is a testament to India's growing space capabilities.
Yeah.
A real symbol of their ambition and their, technical skill.
So we're going to dive into all the details of this rocket and how this launch works. But first, we're going to take a really quick break.
Okay.
We'll be right back. All right, so we're back, and we're ready to really get into the heart of this mission.
Okay.
We were talking about the LVM-3 M4 launch vehicle,
Yeah, the rocket.
the rocket that's going to give Chandrayaan-3 its initial push towards the moon.
Right, the ultimate space taxi service.
Yeah.
Taking us to the moon.
So how does this thing work?
Well, you can think about it as a 3-stage rocket.
Okay.
Each stage kind of has its own job to do, like a relay race to get Chandrayaan-3 into space.
Okay, I like that analogy.
Yeah.
So walk us through this relay race.
Okay, so first up, we have the ignition of the twin S-200 solid rocket boosters. These are the real heavy lifters, providing that initial thrust to break free of Earth's gravity.
Yeah.
Just imagine the rumble as those boosters ignite, propelling the LVM-3M4 skyward.
It must be an incredible sight.
It's quite a sight.
Yeah.
And then about 2 minutes into the flight, those boosters separate. Their job is done.
Okay.
They've handed off the baton to the next stage.
Okay, so who's up next?
Next up, we have the core stage, the L110.
Okay.
And this one uses liquid fuel, and it continues to push the rocket higher and faster.
Okay.
It's all about building up that speed and altitude, getting further away from Earth's gravitational pull.
So it's climbing higher and higher.
Yeah, gaining speed with each passing second.
What happens next?
And then we have the separation of the payload fairing.
Okay.
So this is a protective shell that shields the Chandrayaan-3 spacecraft during that initial ascent through the atmosphere.
Right, to protect it from all that heat and friction.
Exactly.
Yeah.
Yeah, just imagine it like a clamshell opening up,
Oh, okay.
revealing the spacecraft to the vastness of space.
So now Chandrayaan-3 is exposed to space for the first time.
Yeah, and then the core stage, that L110, finishes its job.
Okay.
It burns its remaining fuel and then gracefully separates
Okay.
from the rest of the rocket.
Okay, so the core stage has bid us farewell.
It has,
Mm.
and now the final stage takes over.
Okay.
This is the C25 cryogenic stage.
Okay.
And this stage uses liquid hydrogen and liquid oxygen.
Wow.
Super cool to incredibly low temperatures to achieve those really high speeds needed for lunar insertion.
So this is like the anchor leg of our relay.
Exactly. It's the one that's really going to push Chandrayaan-3
Okay.
towards its lunar destination.
So the C25 engine ignites. What happens then?
Well, this is where things get really interesting.
Okay.
That C25 stage propels Chandrayaan-3 to an incredible speed of over 10 kilometers per second.
That is mind-blowingly fast.
It is fast enough to escape Earth's gravity
Wow.
and set a course for the moon.
So 10 kilometers a second? Are you kidding me?
Note,
That is just insane.
it's incredible the speeds that these spacecraft have to achieve
Yeah.
to, escape from Earth's pull
Yeah.
and reach their destination.
So this whole process from liftoff to spacecraft separation takes less than 20 minutes.
Yeah, about 16 minutes.
Wow. It's incredible how much happens.
It's a lot of action packed into a very short amount of time.
Yeah. A real testament to, the precision
Right.
and expertise of that ISRO team.
Absolutely.
So we've talked about how the LVM-3M4 launches Chandrayaan-3, but what else can this rocket do?
Well, the LVM-3M4, it's not just a one-trick pony.
Okay.
It can handle a variety of different missions.
Like what?
Well, for example, it can deploy multiple satellites into different orbits.
Okay.
So, like a space bus dropping off passengers at different destinations.
So it can launch lots of different things, not just, lunar missions.
Exactly.
What about those interplanetary missions?
Oh, yeah.
Can it handle those?
Yeah, the LVM-3M4 is powerful enough to send spacecraft beyond Earth's orbit.
Yeah. Okay.
So, that opens up possibilities for future missions.
Right.
Maybe targeting Mars or Venus.
Wow.
Or even asteroids.
That's awesome.
It's really exciting to think about.
Yeah, exploring other worlds, searching for signs of life.
Yeah, unlocking the secrets of the universe.
Yeah, that's really cool.
It is.
So it's not just about, the technology behind it. It's really about that spirit of exploration.
Yeah, it's that human desire.
Yeah.
To push the boundaries of knowledge.
Yeah, it's inspiring.
It is.
So speaking of inspiration, what are the scientific goals of Chandrayaan-3?
Well, that's a great question, and one that deserves its own deep dive.
Okay.
So let's take a closer look at the science objectives after a quick break.
We'll be right back. All right, so we are back, and we've gone from Earth to the moon. We've explored the Chandrayaan-3 spacecraft itself.
Yeah.
We've even looked at the powerful rocket that's taking it there.
The LVM-3M4.
But now it's time to sort of get into the heart of this mission, the science.
Yes, the science, that's what it's all about.
So what are some of the big questions that Chandrayaan-3 is hoping to answer?
Well, we still have a lot to learn about the composition of the moon.
Okay.
What exactly is it made of? How did it form?
Right.
Was it once a part of the Earth? These are questions that scientists have been puzzling over for centuries.
Yeah.
And Chandrayaan-3 could help us find some of those answers.
So earlier we talked about the LEABS instrument.
The laser blaster.
Yeah, the one that's going to be zapping those moon rocks.
Right.
What kind of insights could that give us?
Well, these could help us identify the presence of rare elements on the moon.
Okay.
And, these could be very valuable for future lunar exploration and resource utilization.
So, what kind of rare elements are we talking about?
Well, imagine if we found a substantial deposit of helium-3.
Okay.
It's a rare isotope that could be used as fuel for future fusion reactors.
So this would be something that could help us power things in the future.
Potentially, yeah. It would be a game changer.
That would be amazing. What about water ice?
Yes, water ice.
I've heard there might be water ice hiding in those permanently shadowed craters at the lunar poles.
Right. It's a very tantalizing possibility.
Yeah. Could Chandrayaan-3 help us confirm whether that's actually there?
Absolutely.
Right.
One of the key objectives of this mission is to search for evidence of water ice.
Okay.
And, if it's confirmed, it would be a huge discovery, not just for scientific reasons, but also for practical ones.
Right.
Water ice could be a valuable resource for future lunar missions.
Yeah.
Providing drinking water, oxygen, for breathing, even fuel for rockets.
Yeah. It's amazing to think that, something like water ice could be so valuable.
It is. It's essential for life as we know it.
Yeah.
And if we can find it on the moon, it really opens up possibilities for a sustainable human presence there.
So Chandrayaan-3 is not just, looking for things. It's also going to be studying the moon's atmosphere, or its exosphere, I guess.
Well, the exosphere.
Yeah, the exosphere. I thought the moon didn't have an atmosphere.
Well, it's not a thick atmosphere like Earth's.
Right.
But it's not completely empty either.
Right. Okay.
There's a very thin layer of gas and dust that surrounds the moon, and we call that the exosphere.
Okay.
And Chandrayaan-3 will be studying the composition and dynamics of that exosphere.
So what can that tell us?
Well, it can tell us a lot about how the moon interacts with the solar wind.
Okay.
That constant stream of charged particles coming from the sun.
Right.
It can also tell us about how the moon interacts with the space environment in general.
So it's not just about what's on the surface, it's about what's surrounding the moon as well.
Right. It's like taking a comprehensive health check of the moon.
Yeah, I like that analogy.
Yeah.
Now, what about moonquakes?
Moonquakes, yes.
Are those a real thing?
They are a real thing.
Wow.
Although they're not as frequent or as powerful as earthquakes.
Right.
They do happen.
Okay.
And by studying these moonquakes, we can learn more about the interior structure of the moon and its geological history.
So how do we even detect moonquakes?
Well, we use seismometers, which are very sensitive instruments that can detect those tiny vibrations.
Wow, that's really cool.
It is, yeah. It's like listening to the moon's heartbeat.
Now, are there any other scientific objectives that Chandrayaan-3 is going to be pursuing?
Well, one of the exciting things about this mission is that it's also a platform for testing new technologies.
Okay.
That could be used in future space missions.
So, like, what kind of technologies are we talking about?
Well, for example, the Vikram lander, it's equipped with a hazard avoidance system that uses cameras and lasers to identify safe landing spots.
So it's like giving the lander its own set of eyes to navigate that lunar surface?
Yeah, and then the Pragyan rover. It has some artificial intelligence.
Oh, wow.
That allows it to make some decisions autonomously without constant input from Earth.
That's amazing. So it can think for itself in a way.
In a way, yeah. This is a crucial step towards developing more independent and intelligent robots for future space exploration.
So it's really exciting to think about all of the things that we're going to learn from this mission.
It is, and it's not just about the science. It's also about the human spirit of exploration.
Yeah.
And pushing the boundaries of what's possible.
Yeah. And it's not just about India's achievements either. This is truly a global effort.
It is a testament to the power of international collaboration.
Yeah.
You know, scientists and engineers from all over the world working together to advance our understanding of the universe.
It's inspiring to see how space exploration can bring people together like that.
It is. It transcends borders and differences.
Yeah, it really does.
And it reminds us that there's still so much out there to discover.
So to all of our listeners out there, keep looking up at that night sky, keep asking those questions, keep exploring.
Absolutely.
And who knows, maybe one day you'll be part of the next great adventure in space exploration.
Keep those cosmic questions coming.